Thank you very much. Heading up Goldratt Research Labs, I have the incredible opportunity to work with leading organizations around the world in both the private and public sector. There are, of course, many differences, but there's one thing in common, and that's the pressure that they are all under to achieve more with less and less time. What I'd like to share with you today is an approach that we've been developing and have been testing over the last decade or so with great success, and the outcomes of the process is how to do things better. And by better, we mean better quality of service and better coverage, how to do things faster, and how to do things cheaper. Of course, if you can do things better and faster, then it automatically reduces the cost of providing quality services. But there's some other tricks that you could also use for the cheaper part. So what I'd like to do is start off with something that I think everybody has been concerned about, which is what happens if there's a double dip. And my question to you is, what keeps you up at night? Is it the fear of having a double dip in the economy? Well, what keeps me up at night is not that, but the opposite. What if we get a much, much faster recovery? And I want to convince you that if it's not on the radar screen, to really consider the consequences of recovering much faster and attracting even more people into the urban regions with already constrained infrastructure. So the presentation outline, I want to start with why I think that there's a real looming resource crisis and some of the early warning signs and avoidable causes. How theory of constraints, I believe, can help in identifying what the real potential is that can be unlocked to do more with the same resources, maybe even less resources and less time, and show you the process that we've developed, which is a kind of a simplified approach in terms of applying theory of constraints in the thinking processes. I want to show you 3 case studies. We have very short time, only 50 minutes. We have a whole workshop tomorrow where there will be ample time for asking questions if you might have. I'm doing that with Ken Miller, the keynote from today. So I'm going to go really fast through these, but what I want to show you is how you can apply this process in a way of doing things better, faster, and cheaper. And then end off with some recommendations on practical ways of measuring and how you can benefit from this. We're standing on the shoulders of a giant, Dr. Eli Goldratt. He described the scientific method in the foreword of the goal as 2 very simple steps, as to have the courage to face inconsistencies between what we expect to see and what we really have, and secondly, to have the wisdom to challenge basic assumptions around whether those expectations are valid, and if they are valid, whether the assumptions on which we've based our actions were good assumptions. There's an important inconsistency, I think, that affects all of us, and I think it's what I'd like to share with you is maybe challenging some basic assumptions. Quoting Nelson Mandela, one of our heroes in South Africa, and I'm sure many around the world, and I could have quoted many other world leaders that have shared exactly the same vision, not just for their citizens, but for humanity, is that we must, together and without delay, begin to build a better life for all. This means creating jobs, building houses, providing education, bringing peace and security for all. And the question is, how are we doing against that? This is the inconsistency I would like to start with. If we had more time, I could ask each of you, how do you think we are doing in your country and around the world against this very valid and necessary expectation? So you just look at the news and you very quickly can see that we're not doing such great. There's lots of news talking about resource scarcity problems, water scarcity, food crises, energy scarcities, debt ceiling crises, airport capacity problems, population problems. So these are all early warning signals that there's a problem coming. And the question is, will it sort itself out? Is it just a temporary issue? Or is it going to get much worse? So what happens if the demand for something starts exceeding the available supply? Is, of course, you get backlogs. And that's a thing that especially the public sector we are terrified about is what if the demand on, for example, the health services exceeds the available supply? Well, queues will build up. What will control the queues? People start dying before they can get treatment. So when you see these two lines crossing, right, so if the demand is exceeding the supply, you have a problem. And we start seeing it all over the place. Higher unemployment, poverty, delays in the justice system, health system backlogs, education and skill shortages, congestion in the ports, roll and rail, growing solid waste dumps in especially the developing countries, housing shortages, even in developed countries, the UK, Australia, US, in certain areas there are massive affordable housing shortages, water and food shortages. So in many important areas, demand is growing faster than supply. And you can ask yourself the question, why have we allowed this to happen? And is it possible to create the surplus capacity we need to catch up? It turns out that prosperity doesn't come from growth. Prosperity comes from surplus. You can grow an economy without growing surplus. And as a result, not improve the quality of life at all, just making people work harder to pay off the debt. So there's a great quote by one of my heroes, Professor Albert Bartlett. He tried to explain why this is the case. Why do we allow these things to happen? And he said the greatest shortcoming of the human race is our inability to understand the exponential function. Because when you look at the exponential function, initially it looks like it's linear, right? So this could be, for example, the queue that grows in front of an agency that do not have sufficient capacity to cope with the demand. As it's moving towards full capacity, initially the queue is very small. And for a long time it stays quite small until it hits this sort of 80% number, and then it speeds up dramatically towards the top. And of course, it will continue to grow until it hits some kind of limiting factor, and then it slows down and it becomes sigmoidal. So initially we start off with leaders looking at the queues and going, we have more than enough and enough time. No need to worry. And then, help, we don't have enough and don't have enough time. And then it's too late. You've wasted all the time that you had to take some action. So I want to give you a simple example. Some of you might have seen this before, but just to illustrate how quickly this can catch you off guard. So imagine you're a lonely bacteria in a bottle. This is the finite resource, it's the size of the bottle. This specific strain of bacteria doubles every minute through cell division. So here's our bottle, here's our initial lonely bacteria, but very quickly it gets a lot of friends. So every single minute it is doubling in the number of bacteria in the bottle. And you can see what happens on the side there of what happens after X amount of doubling times. So after the first one, there was 1, then 2, then 4, 8, 16, 32, 64, 132, 256, 512, 1. Anybody that knows computer language kind of can predict what will happen. After only 60 repetitions, so after 60 minutes, you have 2 to the power of 59 bacteria, or 576 quadrillion very tightly squashed neighbors in this bottle after only 60 doubling cycles. So a few simple questions. At what time from 0 to 60 do you still have 75% of the space in the bottle left? Now it's almost impossible to predict that unless you go backwards and you say, well, if we double every minute, then minute 59 we've got half the space left. Does it make sense? We still have half the space left at minute 59. So you can imagine the guys are going, starting to get a little bit cramped in here, but we have plenty of time. Took us 59 minutes to get here. Still 50% space. Looks like the growth is linear, so we've got at least another 59 minutes before we should start panicking. Of course, at minute 58, you still have 75% of the space left. The question is, at what time will you start making the alarm that we're running out of this scarce resource? What do you think? right? Probably very close to 60. What do you think people will think of you when you start screaming, guys, we've got a problem, any time before that? And then, of course, sometimes we're lucky and we've got a great visionary leader that starts realizing we've got a problem, and they send out this team of guys to go and look for more bottles. And they come back just in the brink of time and they go, guys, we saved, we found 3 more bottles. And everybody goes, unbelievable, you know, this is just, you know, our guys always do it for us, you know. Well, how much time will 3 bottles give you? Right? Another 2 minutes, right? That's it. So the question is, what time is it for humanity in the consumption of some of our scarcest and finite resources? And it takes to look at the kind of the population growth that we've experienced. So when I was born, 1969, we had 3.5 billion people. 42 years later, we had 7 billion people. So immediately, you know, our doubling time is about 40 years odd, right? So if it continues, by the time I'm about 100, we'll be getting close to the 14 billion. Of course, there's not enough resources to tolerate that. So the UN projections is that we probably won't exceed 10 billion people. So this is where I'd like to start, is to say what happens if you're recovering faster is that it sucks more people into the urban areas. And these urban areas are already constrained. Which of you are living in a city that do not have congestion problems already on the road? Or problems with infrastructure like solid waste management, right? Or buildings that are running out of space. So this is really what I'd like to talk about. And you can also ask, well, we have known this for a long time, right? The Limits to Growth was published in 1976, I believe. And what they were predicting was what's going to be happening with all these key things. What will happen to population, to food, to industrial output, and when does it start collapsing, and what is the sensitivity in the regions? And what will happen to life expectancy? And you can see life expectancy wonderfully going up until you hit that limiting factor, and then it starts coming down. So in many of the areas already, they simply are not producing enough food to feed all the people. So what do you have to do? You have to start importing food. And that makes prices go up. Exactly when you need to have prices coming down. So this has been known for quite a long time, and yet it seems as if governments are not paying attention to not the dip side of the economy, but the upside of the economy, because both of those have got really negative consequences. So there's not much that you can do about it. The obvious answer is slow down population and urbanization growth, right? And you know, our calculations about China is by limiting the population to 1 child, they've taken about 300 to 400 million people already out of the equation. It would have been an absolute disaster if they never instituted it. And at least in the areas that we've checked, it's instituted in a very practical way. You want to have 2 children, fine, but then your tax rate goes up, right? Why are they doing that? Because they understand that being the biggest brings with it huge responsibility. Because a 2% increase in your population is equivalent to a 20 or 50% increase in the population of everybody else. So I'm not going to be focusing on number 1. What I'll try to do is to say, well, there's 2 other things that we could do. We could try to squeeze more out of the limited resources that we've got, and we can accelerate the development of the necessary infrastructure to try and catch up on this gap that's already large and make sure we stay up to date. And that's really what theory of constraints provides. It provides us with a very simple focusing methodology that says if it's true that the chain is only as strong as the weakest link, be clear about the goal, because else you won't be able to define what is constraining you from achieving that goal. So if the goal is better quality of life for all, what is going to be constraining us? What is the system constraint? And how does it relate to the specific agency, for example, that I'm investigating? So one of the case studies I'll present is related to solid waste management. Now, you don't need to be a genius to find a bottleneck in this case, you look for the dumps of garbage that are piling up in the streets, right? And you know the bottleneck, like in most cases, are just behind that pile of stuff. Right? That's where the system is clogging up, like Ken said this morning. Right? This is a pipe, and where's the pressure building up, and how do you see it? You see it in stuff piling up, a backlog of stuff piling up. So clearly the bottleneck there is in a collection of this garbage. So you have to check, what can we do to better exploit this scarce resource that we have, which is maybe the trucks to go and pick up the garbage and move it into landfills. How well are we exploiting the current trucks that we've got available? How many hours a day are the ones that we have running with garbage on it, right? That gives us an idea about what the potential improvement is to do more. Of course, the traditional way is if you say to them, you need to get more garbage collected, they say we don't have enough trucks. We need more trucks. And then the capacity building organizations come and pitch in and they try to raise funds to get more trucks. Almost never, nobody says how well are we utilizing the trucks. Would you be surprised to find out it's around 30 to 40%? Now that means that you could probably, with a little bit of effort, double the output of that bottleneck resource by just moving it from 30-40% utilization to 60-80% utilization. So that's what step 2 is about, is deciding how to better exploit and not waste the scarce resource. Whether the scarce resource is the trucks that we have or the land that we have to plant food on. Step 3 is the challenging part. It says subordinate everything to this decision. Any policy, measurement, or behavior that's in conflict with a decision about how to better exploit the scarce resource and not waste it, you have to change. But only that. Don't change anything else. If it's not enough, then go and elevate, right? So once you've shown that you're squeezing the most out, now that the opportunity is to go and elevate, now go and get more trucks. The warning is, don't just stagnate at a higher level. If a constraint has been broken, go back to step 1. But if you're thinking about how to manage the system, the trick is never to get to step 5. You want to keep the constraint in one area because then the rules of managing the system stays identical. You don't have to change the rules if the constraint stays in the same place. But if the constraint moves, you have to change the rules again. So try to keep the constraint in the same place. So a more strategic way of applying the 5 focusing steps is not identify the system constraint as step 1, but decide where you want it to be. Because this is the way that we will control the management of the system, by only looking at the constraint, making sure it's never starved, never blocked, never down, and making sure that everybody else is aligning their behaviors to ensuring that happens. If the constraint moves to another area, we'll have to figure out, okay, now what will it take to ensure that that thing is never starved or blocked? And that's where we introduce a lot of instability. So graphically, the kind of process looks like this. Step 1, where's the constraint? Find out how big the gap is between how much the system is getting and what the nameplate capacity of that bottleneck is. The system is currently doing 10. The bottleneck can do 20, we're losing about 50% of the output. Deciding how to exploit the constraint are what are the conditions that if we could satisfy, could get more out of the system. How much capacity are we losing because of downtime or setup, starvation, blockage, rework? Overproduction is a big one. Overproduction is wasting that scarce resource capacity doing things that shouldn't be done now. In a software company, if you think about it, the bottleneck might be the developers that are developing new functionality and solving the bugs, right? So when you look at their utilization, it looks like these guys are already working 12 hours a day. So there's no way to squeeze more out of them until you ask the question, how much of the functionality that they develop in the software is actually used by customers? Turns out to be about 20%. So 80% of their productive capacity is wasted producing stuff that is not needed or not needed ever. And that's what step 2 is all about, is finding out how big this gap is, where we're wasting scarce resource capacity doing things that shouldn't be done now or ever. And then subordinate says, what's the conflicts that blocking me from making the changes? On the one side, there's pressure to change the rule, to ensure that the bottleneck is never starved, blocked, etc. But at the same time, there's pressure not to change the rule because of some local optimization. And then only to elevate, and even elevation carries with it some conflict about adding additional resources, and we say we can't do that because we have to be fair. Well, managing a system has got nothing to do with fairness. It's all about, can I better exploit and elevate the system constraint? So what does it mean in terms of performance? When you look at any system like that and you map the process out, what we're trying to do is we're trying to see what's coming out the end, and what is the gap between what's coming out the end and what the bottleneck is capable of doing. So the output is 10, but the bottleneck can do 20 a day. Okay, so there's a gap of 10. Where are we losing capacity due to starvation, blockage, overproduction, etc.? That gives us an indication about how much we can increase throughput by. Now, throughput in a government agency is not necessarily doing more because you've got people arriving that you really can't control. It means doing better quality and better coverage of the people that are arriving. The potential to reduce lead time, as Ken showed this morning, is essentially thinking about the big gap between the total time the person stays in the system and the physical touch time of working on that person, right? So, for example, a patient in a hospital, the total length of stay versus how much contact time they actually had with medical practitioners. Or I go and apply for a passport, takes the agency 4 months to give me my passport, and yet the touch time is only a few minutes. I know that there's some fantastic results that Chris will show in her presentation on this huge gap that they found between the physical touch time and the total lead time. Normally it's good to assume it's about 95% is the possibility of reducing it. So you should be able to do things much, much faster. And of course, when you are not meeting the demand and when things take longer than expected, you end up incurring a lot of unnecessary cost and investment. And as a result, if you can improve the flow, a lot of those things will come down. A lot of those avoidable costs will go down. And that's why we feel quite confident to claim that in all cases we should be able to do more with less resources in less time. The better, faster, cheaper. So that's just a quick introduction of TOC in terms of how we apply it. When you look at the performance that is achieved by for-profit companies when they apply theory of constraints, it is not a 5% improvement or 10% improvement. It relates to the size of these gaps that I've mentioned. So it's not uncommon that you are doubling the throughput with the same resources. It's not uncommon that you're cutting lead times by 50% or even more. And what I'd like to ask you is just think for a moment, what would be the impact on a country like Lithuania if you could improve to such an extent all the critical government processes that are impacting the quality of life of people. Not improving them by 2% or 5%, but improving them by 20%, 50%, 80%. And that to me is the exciting part of what we do with theory of constraints. So you're focusing directly on the area where an improvement will bring the most benefit to the system. And ignoring those areas that, yes, maybe we're not following best practice, but it's good enough. Don't get confused between gaps between my actual performance and best practices and gaps between the constraint performance and what the demand is. That's the important gap to focus on. The first one is going to cause local optimization, causing you to try and focus everywhere because there's opportunities to improve absolutely everywhere. So before I go into the case studies, maybe just a quick question for you. Where do you think improvement is needed most? In the for-profit organizations to ensure that we get the economic growth that we want? Yesterday we had a conference with small to medium-sized businesses talking about how to improve their competitiveness, because those are the businesses that typically create the jobs that we all need. And if they're not competitive, there's no reason why they will be rewarded with growth and why they will attract more people to come and join them. Should it be the education system? Is that the biggest problem that we should solve? Or the health system, or agriculture to ensure food security, or mining to ensure the availability of natural resources, or energy, or airports, or housing and other infrastructure problems, or maybe emergency or poverty relief? or accelerating time to market of some of the new exciting technologies and drugs that are coming up. Well, what we've seen with theory of constraints is that each of these areas are getting attention by different groups, and that's the good news. So what I'd like to do is let me take you quickly through some case studies. I'll start off with the first one, which is an incredible opportunity that we got. At the time I was busy doing my PhD, and I developed a process that was based on a very simple premise. It says that the bottleneck is at the top of the bottle. It's our own assumptions that limit us from achieving higher levels of performance. So if we could come up with a process that quickly identifies what the limiting assumptions are of the various stakeholders to do more with less and less time, that's a practical way of unlocking a huge amount of potential. It's a repeatable process. If you could come up with a generic process to take people step by step through to find out what's blocking them really from doing more. And it's not that they don't have enough resources. It's that they're not utilizing the resources in the best way. Why? So I developed this process, and I was looking around for a way of testing it. We had already tested it in the private sector and with individuals, but I was looking for a test in the public sector, and an organization called Invent, the capacity building organization in Germany, came at one of the conferences to me and said, Alan, we've got a potential project for you. Can you help with? We've got some city councils in Africa that have applied for funding to help them deal with this problem of solid waste management where dumps of garbage are building up. Can you come and help? And you are welcome to come and test this new process. I'll also show you just some results that have been achieved in a direction of how to solve the affordable housing crisis, a project that had been done some while ago and a new one that we've just started. And then in terms of the cheaper one, like I said, is when you do things better and faster, a lot of the avoidable costs go away automatically. So cheaper becomes an effect rather than another thing to address. But there are some independent causes for why we are not able to better utilize budget, for example, how we waste budget. So I want to just give you a hint, and maybe that sparks some insights on how you can apply it in your own organization. So when I developed the engagement model, I wanted to make sure that the engagement model that we developed are robust and scalable enough to be used in all types of organizations to identify and unlock potential. I looked at the adoption and sustainability of the process and said it had to be based on a systems approach. It can't be based on looking at local improvements, which is most of the capacity building things are looking at that. They have some kind of benchmark that they rate the city council against. It identifies a gap between your performance and the benchmark, and then they try to close the gap. It's based on an assumption that by closing the gap, your goal units will go up. In most cases, it doesn't, because it's not the constraint, right? So if somebody pays attention and said, guys, it's been 2 years since we've built the capacity in this area, we've improved the performance, are we really getting more of our goal? They would have seen that there was no impact, which meant actually, yes, it might not be the best, but it's at a level of good enough. It's not the constraint at the moment. So it had to be based on a systems approach. It had to be inclusive of all stakeholders. And a valuable lesson that we've learned is when you get an opportunity to have a workshop, whether the workshop is 30 minutes long or 3 days long or 5 days long, make sure everybody's there. That's a key stakeholder, because it's tough to do rework if somebody is not in that workshop, because the guys in the workshop are going through a discovery process all at the same time, and they're building a team, and they're getting excited, and then they have the tough job to go back and explain it to somebody that wasn't there. And of course, their ability to communicate what they've discovered is not yet at the level of good enough, and they make a mess, and then they find that they struggle to get the buy-in. So it's a prerequisite that this has to be inclusive. Make sure everybody's there. Make sure that the process that we develop is actually transferable, and that was my biggest fear, is that yes, maybe I can do it. I've been doing what I do for a very long time, and we don't have 20 years to train people. We need to develop a process that's simple enough that it could be repeatable. So from the beginning, we said, I'll do the first 2 workshops. I'll train trainers, I'll sit in when they do the next 2 workshops, we'll debrief them, we'll correct mistakes, and then they must run, and we want to see if there's not too big of a variation. And lastly, the process itself has to be simple and fast, and it has to be fun, and it has to deliver actionable information. It can't be a normal capacity building exercise where we deliver training and not actionable information. And actionable information is we walk away with everybody clear, what are we going to do, when do we need to do it by, and how will we measure our progress. So the process that we developed starts with why change. The diagram might look complicated, but we try to explain it very simply. We say find the constraint or the bottleneck, that red thing where the stuff is building up in front of it, like in this case the collection of garbage, and ask every stakeholder present in the workshop to tell us what is making it difficult for them to understand, first of all, what the full consequences is of this gap between the demand that's placed on that resource and the current supply. So we bring experts in that come and tell us in the first day, literally the first hour of the workshop, what will happen if we can't close this gap. All the stakeholders come in. Health department says what will happen. The Justice Department says what will happen. And then we ask them, for the stakeholders that you represent, what are the things that make it difficult for you to contribute to close the gap? So they understand the consequences of not closing the gap, and I have an opportunity to share what makes it difficult for them to contribute to closing this gap. Not blaming somebody else for not doing their job, what makes it difficult for them to contribute. And if there's nothing that they can do, why are they in the workshop? Luckily we haven't had that because we do our homework before the time. What we then do is we ask them to write the conflicts related to this. And there's 2 conflicts. There's a problem that they're blaming. It puts them in a conflict. And they are blaming somebody. So understand the conflict that stakeholder or person was facing in terms of causing the problem in the first place. And because there's such a distrust between these stakeholders, we thought that by putting them into the shoes of the one that they're blaming, they'll be in a much better position to understand that it's not negative intent, but they're stuck in the same conflict. Find a way of resolving the conflict with a win-win. Make sure that it will give us all the desirable effects, is what the DEs stand for, and check for all the yes buts that can block the implementation. Develop an action plan, come up with measurements, and start the implementation. So in terms of solid waste management, we had this opportunity in 2007. The objective was very simple. It was how to help them achieve more with less and less time, and as part of the Sustainable Cities program. It was specifically focused on solid waste management and water supply in the initial cities, Zambia, Kenya, Nigeria, Tanzania. Those were the countries that applied, that gave us cities to do these pilots in. And as I mentioned, it was starting off with understanding the negative consequences of a massive and growing gap between the demand and the supply in infrastructure. So what does it kind of look like? We know that governments are responsible for ensuring that garbage is collected, transported, and disposed. Normally, a part of that is outsourced to private contractors. They have service level agreements to actually provide the services, but often, especially in the developing countries, these services are not extended to the very poor because they live in areas that are very difficult to access, or they cannot pay for the service. So when we looked at the consequences, you can see the kind of pictures of what a city might look like when you have a problem with solid waste management. And it was interesting, before we started, the capacity building organization warned us that as part of our efforts to get everybody there, you basically have to pay for their transportation to come to the workshop and their accommodation, because it's an on-site workshop for 5 days. And I said, look, based on our past experience, we know you guys are very passionate, but there's high distrust between these individuals that will be there. Don't, be shocked when they are getting into serious arguments. Don't be shocked when people leave as soon as they've received their daily allowances, because some of them see it as an opportunity to make a bit of money. You know, they find a cheap way of getting there, and then they get paid a $1 per kilometer and they can make some money. So don't be surprised if there's a high dropout rate or people fall asleep because they've had to travel far. So we were really kind of, you know, prepared for walking into an environment that's absolutely non-ideal. So what did we find is in the first city that we looked at, Lusaka, what we found, population of about 2 million inside of the city in 2005. Each of them generates about a 0.5 kilogram of garbage every day. So it's about 1,000 tons of garbage generated every day. The formal system is only collecting 200 to 300 tons a day. So 700 to 800 tons per day is left to be buried, dumped, or burnt. All three of those things are not only illegal, according to the bylaws, of course, but has got major negative consequences for all. And more importantly, it was expected that just in the next 10 years, and this turned out to be a reality, that the population will double. The doubling time through urbanization is about 10 years. How do you calculate it quickly? For those that are in finance, there's this rule of 70. If you want to calculate the doubling time of anything, take the rate of growth, take 70 divided by the rate of growth. So if you're growing by 7% per annum, which sounds quite reasonable and not that much, which is the common urbanization rate, you've got a doubling time of 10 years. And why is doubling time so important? When you think about doubling, we go from 1 to 2 to 4 to 8. 4 is 1 more than 1 plus 2. 8 is 1 more than 1 plus 2 plus 4. This means that in the next 10 years, when you've doubled, not only you will double the consumption, but you'll have more consumption in the next 10 years than the sum of all the consumption since the beginning of time. Does that sink in? You can see how bad the problem is, right? The same with food production. If our doubling time at the moment from a population perspective is about 40 years, it means in the next 40 years we'll have to produce more food than humanity has produced since the beginning of time, just to cope with the doubling. So doubling is a really important thing to understand, and that's why this Professor Albert, he says he thinks it's our misunderstanding of the exponential function that's to blame for many of these problems. So we share with them on day one just brief insights to try and keep it as simple as possible, to explain what happens when the demand starts exceeding the supply and why it starts accelerating, why is it exponential. We explain to them the focus that TOC brings in focusing on the bottleneck and how to exploit first before you try to elevate, and that the key to understanding what's blocking you is to write the conflicts that's blocking the various stakeholders from making the changes they know they should be making. So we start off with the supply chain. In this case, you know, the waste creation, waste collection, waste disposal. The bottleneck is clear, it's on the waste collection side. We look at how big the gap is, and we ask them to tell us what makes it difficult to close this gap, and what has previously been assumed to be the root causes, and what has been done to solve them. So if the root cause is a lack of awareness of how bad it is to dump garbage, then let's create some awareness campaigns. Produce brochures that add to the waste dump. You can see how useful that is, right? As if people don't know how bad it is for them. It's like the problem with smoking. Do people that smoke really not know how bad it is for them? Of course they do, but they're stuck in a conflict. So what we do on the first day is we show them that none of the previous things that have been tried have actually made any benefit or resulted in any benefit. If you don't do this step, people will think that what they got currently in the next 2-year or 5-year plan, if they just do more of the stuff, they'll get the benefit. So unless you get them to agree to stop those things, because they're not working, right, you won't get them to be open or have the attention or capacity to do other things. So that's an important part of the day one. We then ask each of the stakeholders to tell us specifically for them what makes it difficult, and why is it bad for the system? Why should we not just ignore it as a bitching and moaning session? So the City Council say some franchise contractors don't meet the demand even if residents pay. Why is it bad? Residents get negative attitude, waste piles up, and all good starting efforts go to waste. And we do that for each of the stakeholders. We then ask each of these stakeholders to write 2 conflicts. As a small example to illustrate what I mean, say the problem is that we've got too much inventory of a specific item, right? I'm in sales. What's the conflict I face? On the one side, to reduce the price to get rid of the inventory, but on the other side, to not reduce the price to protect my margin. Who are they blaming for the high inventory? Sales are blaming the production guys for producing the stuff. So what action are they blaming is that production keeps on making to forecast. Whereas if they had made to order, we would never have had the problem. So by getting the stakeholder to write the problem, why it's bad, which is the top part, how this puts them in a conflict, and that's why they're stuck, but also putting themselves in the shoes of the other stakeholders, what's their conflict, it really builds trust and respect very, very quickly, because now it becomes us against the problem, rather you versus me. So when you look at how they've applied it, you know, City Council says, well, residents won't pay. The problem is it puts us in a conflict between stop providing the service to non-payers versus continue to provide the service. Who are they blaming? They're blaming the citizens for not paying, or they're blaming the people that are not enforcing the bylaws. So we do this for each of the stakeholders. They do it in flip charts, and the group moves around and they come and explain it to us. And it's like a big thing gets dropped off their shoulders, because now they can explain, you see guys, it's not that we're incompetent or that we don't care, we're stuck in a conflict. And by the way, we've been blaming you for all this time. We also understand the conflict that you're facing. What we then do is we look at these as specific conflicts and see if they're not some generic conflict underneath it. So we try to find the core conflicts or generic conflicts. So here are 4 that we found to be existing in almost any city council. On the one side, the pricing conflict, which is to price based on the supplier's perception of value. So the supplier determines the cost and add a margin, or based on the customer's perception of value. The payment conflict for the citizens to pay or not to pay. The conflict that the service provider is facing, which is to invest or spend more to meet all the demand versus not to do that and only meet the demand of people that are paying. And then the enforcement conflict, which is to enforce bylaws or not to enforce bylaws. And each of them have challenged the basic assumption and have come up with a win-win solution to achieve both of the objectives. For example, those citizens that can pay should, and those that can't pay can pay in kind. For example, they can volunteer to separate the waste of their neighbors, and as a result they don't have to pay. So practically they get the kids, they make it a bit of fun and say, okay, all the garbage are piled up, let's help everybody separate it, and that makes it possible for the service provider to start being able to sell the garbage, because they can now sell the metal component, the plastic component, where if it's all piled up, they just take it to the landfill. This is very contrary to a previous policy that these capacity building organizations had. They had a policy that you should pay for service, regardless of how poor you are. Now, practically that means that a family had to take their garbage to a skip that might be 2 kilometers away, and when they get to this garbage skip, they had to pay to put the garbage inside. And they were surprised that this wasn't that popular. You know, and as an engineer, I go, duh, like, would you do that? No. So clearly this policy, it's based on a very nice principle and value, but keep that for yourself if it's such good values. Let's look at something that will really work. So this is kind of what we did. We then looked at all the yes buts. What can block people from implementing this change that we've just agreed on? Why is it not sufficient to give all the wins? Why could there be some potential negatives or implementation obstacles? Really allow them to raise all the yes buts and see what we need to add to our plan to overcome those yes buts, and then build what we call a strategy and tactic tree, showing all the changes and the sequence in which we have to implement the changes, because we don't want to multitask. We want to do them one at a time, measure the impact of each of them, convert them into a project plan, and start monitoring. So that's kind of the, this is basically how it looks when we're facilitating the process. We've had some really fantastic feedback from private contractors. I really didn't expect much. It was great to see how all the stakeholders can work together towards the same goal. The Director of Waste Management, I thought we can only close the gap by getting more equipment and new equipment. Now I learned that we can use the same equipment. The hospital manager saying that, we knew that the cost of doing nothing is a matter of life and death, but TOC showed us that by better exploiting our existing capacity, we can make the cost of doing something zero. And that's a big breakthrough, right? Normally we compare the cost of doing something with the cost of doing nothing. The Deputy Mayor said that it was, for him, really important to see how much time we spend on defining the problem precisely as an unresolved conflict, because all that we normally do is we go problem-solution. Turns out that the solution is just one side of the conflict. We have problem, solution is centralized, but there's another side that says decentralized. So it was really amazing, and part of our pilot was to have an independent auditor's report come in and give an objective analysis of all the pilots that we did. And this is from the executive summary. If any of you are interested in this report, just send me an email and I'll forward it to you gladly. They said the main observations is that the overall objective of testing the application of TOC to public sector infrastructure setting was fully achieved. The impact can only be described as a shift in paradigm. Significant improved operations were achieved using the existing resources. This increase was between 42.5% and 87.5% within the various city councils that have been checked. So a really positive feedback for us. So just in summary, there's a big gap in many of these agencies or the service that they're providing. There's two ways, of course, of closing the gap. In this case, reducing the amount of waste created. And there's some fantastic technologies and resources for doing that. We focused on how to increase the capacity of the supply side. 3 important steps: make sure all the stakeholders are present, recognize past achievements, and getting agreement of what needs to be done, who's going to do it, and what will be the steering committee that runs it. And just a last warning, vision without execution is a hallucination. Great quote from Edison. So this is not just about building capacity. Without follow-up and follow-through, things are not getting done, whether you're in a private sector or the public sector. So part of the mandate of the capacity building organizations have to change. So how to do things faster. Example of this big crisis in terms of housing, a great graph, and you can read through that in your own time about what happens if the horrible consequences if we don't have houses. An interesting experiment that was done in 1999, the Habitat for Humanity world speed record for completing a 4-bedroom house was attempted to be broken by a team that was using Goldratt's critical chain technique. They ended up building this 4-bedroom house in 3 hours, 44 minutes, 59 seconds. Ken was talking this morning about a 7-day record. 3 hours is a little bit better. If you're interested, there's a documentary that was made about it. And the criteria for completion was that a family could move into the house. They started with a clean plot. Literally less than 4 hours later, complete house standing. And really think about what's delaying the process. There was a technology innovation of getting concrete to dry faster, but the biggest thing was just making sure that the project is not waiting for any resource. Another interesting project that we've just started also with Australia is an interesting graph that you'll see here. This is over the last 30 years or so. What you see as the blue line is the number of dwellings under construction. So typically the industry responds to a growth in demand by putting more houses into construction. The red line is the number of dwelling completions. And what you've seen is that there has been basically no increase in the completion rate. which means that there's a capacity constraint. And we're very confident that, you know, applying these very simple insights from theory of constraints of how to do things faster by reducing delays, we can actually practically increase dramatically the completion rates. And we've gone through the multitasking exercise that shows the terrible consequences, what happens if we try to multitask in terms of the lead time versus if we just did these projects one by one. So the 3 projects at the top is, say, construction projects of homes. In the middle, scenario 1 is when you do them by multitasking, when you have the crew traveling around working a little bit on A, then B, then C, then switching back to A. And below the line is what happens when you simply do one project at a time and you finish it, and a dramatic saving in time and time-sensitive costs that you can get. The last case study that I want to quickly share with you is, as I mentioned, when you do things better and faster, quality throughput goes up, avoidable cost goes down, which means that the total cost per quality service unit will go down. But there's another way of looking at it, and I had the opportunity to work with the largest emergency relief agency in the world. And the question was, where's the constraint in the system? They get donations of food and cash. It has to be converted into stuff that can relieve an emergency like hungry people. So where's the constraint? And the assumption it was in donors. And what we found was that that was not the case. Really what was happening is there's a kind of a forecast that's required by the regions to be given about how much aid do I need in money and cash. Because people can die, you expect them to overestimate a little bit, right? Because they literally can't wait. So what you would expect to happen is that as the emergency relief success efforts happen, these stories are publicized, you'll get more donations. And that the stuff that's not needed after the relief effort is over will be returned back to the central distribution system for the food or the central bank accounts. But of course, because there's this policy of if you don't use it, you lose it, or the fear of that, most of the stuff stays at the regions. And what we did was a simple exercise to say that why don't we exploit really the power of the law of aggregation by not giving everything that they ask for, but keeping a portion back. If they really need it, it will be immediately available, whether it's food or cash. But if they don't need it, we don't put them into a moral dilemma of using stuff because they're scared that they will lose it. And we've had a significant saving here. I think maybe Chris will mention something tomorrow. We just started a project in Utah to see if we can do this at a budget level for a state, because the same type of problem is there. How do we measure it? To end off with is there's a few practical ways. A cumulative flow diagram is a really practical way for any agency to see if they are meeting demand. So the red line is cumulative demand on that agency, so patients arriving at a hospital. The green line cumulatively is the release of those people, the completion rate. And when you look at it cumulatively, you can read directly off the graph what is your supply lead time on average, how long does it take us to process. So for example, the length of stay in a hospital, and vertically you can read off directly the work in process or the number of beds that's occupied. And you can see what happens if you had a small increase in demand, but you don't have catch-up capacity, you will permanently increase your lead times and work in process, or the number of beds that's required if you can't catch up. The same thing is true if there's a small delay in the supply side, a strike happens or whatever. Unless you have the protective capacity to catch up, you'll permanently increase lead times. We also look at, for example, what percentage of the work that's being done within the target time. That gives us an opportunity. And measuring productivity as QT, the quality throughput of that agency compared to their direct operating expenses. And what you want to see over time, if they're becoming more productive, that the quality throughput is going up faster than what their costs is to provide that service. So I'll end off with some basic insights. Doing it better what does it require? It means find a bottleneck, see how big the gap is between the output of the system and the bottleneck capacity, find out where we're losing capacity, starvation, blockage, overproduction, downtime, and take actions to reduce those losses. That will allow you to do better quality and better coverage with the same resources. Doing it faster means looking at the time difference between the elapsed time and the touch time and understanding why things are being delayed and reducing those delays on the longest chain. And lastly, doing it cheaper. If you do number 1 and 2, it should already become cheaper, but also think about treating the available budget as the constraint and seeing how we waste that constraint by not benefiting, for example, from the law of aggregation when people think that use it or lose it is true. So thank you very much for the time.